is in a triangle, and it is a segment that joins the vertex to the midpoint of the opposite side. All right, so we looked at some perpendicular bisectors that happen to go through the vertex, but they don't always. Perpendicular bisectors do not always go through a vertex. A median always goes through the vertex. You'll notice that it does not always go in at a right angle. In this particular case, it isn't at a right angle. The only time it will go in at a right angle is if you have an isosceles triangle, like we looked at when we did our first section of perpendicular bisectors. So it starts at the vertex of one of the vertices, and it goes through the median, the midpoint rather, of the opposite side, which means that these two small segments are equal. They're congruent because it hits at the midpoint specifically. So then the three medians of the triangle intersect at one point. They will intersect at one point, and this point is a new term called a centroid. A centroid. Centroid. So let's look first at what are the medians here. Well, the medians would be from a vertex like B down to the opposite side, F. From a vertex like A down to the opposite side, E. And from a vertex like C down to the opposite side, D. So those three would be your medians, AE, BF, and CD. So the centroid is where those three intersect. And those intersect at the point P. Now the centroid creates really unique pieces of this particular triangle. So we saw on the other ones that it also created some unique things that happen if it goes through the vertex and things like that. But in this case, it has some different properties that are specific to the centroid. The first one we're going to talk about is the fact that it creates two pieces here. So A to P. So if you look over here from A to P, which is from the vertex to the centroid, is exactly twice as long as from the centroid to the midpoint of the opposite side. So they're exactly double. So from the vertex to the centroid is always going to be double the rest of that distance, okay? So from the vertex to the centroid is going to be double that distance from the centroid onto the other side, which means that that short piece of your median, the short piece of your median is going to be exactly half of the other piece. So the median is actually divided into three parts, right? It's divided into the short part and then the double of that short part. Okay, so from the vertex to the centroid is going to be exactly double the distance from the centroid to the midpoint. So that median is going to be divided. Okay, it's going to be divided. Now, if you look at it that way, so we have from P to E, and then you should have two of those that look just like P to E, right? So P to E should be able to fit twice on that other piece, all right? Which means you have this unique thing that happens. It means that AP, so the long piece of this, is 2/3 of the whole thing. So while this is double the short side, this is going to be 2/3 of the entire median. So this long piece, you can find it two different ways. The long piece is going to be double the short part of it, or it's 2/3 of the whole length. 2/3 of the whole length, all right? Which means the short piece should be 1/3 of the whole length. Okay, 1/3 of the whole length. All right, so this short piece of the median should be 1/3 of the entire length of the median. All All right, so it really divides it into these special relationships here. Which means if you have one piece of it, you can very often find lots of pieces of it. All right, so let's look at these examples, the first two examples here on this page. The first two examples. If P is the centroid of this triangle, JK is 22, KN is 13, and OL is 18, find each measure. This is where I would probably recommend some colors, right, so that you don't lose where you are. So from J to K, they have given me this side length here is 22. So how does that help me? Well, I know that M should be the midpoint of that side. If I have a centroid, I know the median goes from a vertex to the midpoint, all right? So I know that it should have cut that side in two perfect pieces. So the first thing I'm going to look is, how does KM help me? Well, how does JK help me? Well, it's going to help me on this first one, K to M. If I know that the entire side length is 22 and that it cuts it directly in half, then from K to M should be what? 11. Or if they had asked me from J to M, that would also be 11. That's not one of the ones they asked me, but if they had, I could have easily found that one as well. All right, so I've used that piece of it. I know that that is going to be 11. So what else did they give me? Well, they give me K to N is 13. So K to N here is 13. All right, again, medians hit at the midpoint. So they told me that this piece of it is 13. And the very next question they're asking me is N to L. Well, if K to N is 13 and N should hit at the midpoint, how far is N to L?
13.
It's also 13. So that is also 13. And then the last thing they gave me was O to L. O to L. All right. And they gave me that as 18. So I have this as 18. So let's look at the other three pieces that they want. All right. They want K to L. So they want all the way down to here. K to L. Well, I already found the two pieces. If K to N is 13 and N to L is 13, how far is K to L? It's 26. All right. They want J to O. Yeah, we already know half of it, so we know this is going to be 18. And then they want J to L, so that one's going to be what? 36. All right. Any questions on that? So they gave us T to Z, which is from a vertex to the centroid. They gave us X to Z, which is from the midpoint to the centroid. And they gave us W to Z, which is also from the midpoint to the centroid. So the first thing they asked for is Z to V. Z to V. So for this one, from Z to V, if I know that the short piece of my median is 28, what do I know about that compared to the long piece of the median? The short piece of the median compared to the long piece of the median. What do I need to do to the short piece? So the long piece of the median is exactly double the short piece, okay? So I just need to multiply by 2. So I should have gotten what here? 56. You think? Okay, let's look at the next one. From Z to Y. From Z to Y. Okay, so they gave me the long piece here. So they gave me the long piece here, the 60. That means the short piece should be exactly half of the long piece. So I'm just going to divide it in half. You should have gotten 30 here. 30. All right. And then from Z to U. From Z to U. Which piece did they give us on this median? What piece did they give us? The small or the long? The small piece of it. So what do I need to do to it? Double it. What should you have gotten here? 50. All right, so now they're going to ask us about the entire median length. Now here's the thing. We've already found the 2 pieces of them. All right, we've already found the 2 pieces of them. They want from T to Y. T to Y. Well, I already know from T to Z is 60. I figured out that from Z to Y is 30. So what is T to Y? 90. All right. The last one they want is X to V. X to V. Well, I already knew that X to Z was 28 because that's the short piece. From Z to V was 56. So how much should my total have been? 84. All right, so the altitude. Altitude is a segment join the vertex to the opposite side so that it is perpendicular. So specifically, we are looking for perpendicular to that side, all right? So you want it to be, specifically, you want it to be perpendicular. Perpendicular to that side. So this is different than the median. The median went from the vertex to the midpoint of the other side. We didn't care about the angle that it hit it at, okay? In this case, we do not care where it hits the other side. We only care that it hits the other side at a right angle. At a right angle. Now here's the thing about altitudes. Altitudes do not always fall inside of the triangle, all right? Now if you have an acute triangle like this first one, you will find that it does fall inside, all right? So you'll find that specifically it is inside the triangle here. So if I go from the vertex down at a right angle, I am going to be inside the triangle. But if you look at the next one is an obtuse triangle, okay? And you can see here that if I were to go from that top vertex down, perpendicular, my altitude actually falls outside my triangle. That's okay. It is important that it is right angle. That's what makes it an altitude, okay? This last one is a right angle. And so if I go straight down here, well, it's supposed to be a right angle. It's actually on the side itself. The side itself of a right angle is an altitude because it already hits the other side at a right angle. All right, so what's important is that it is perpendicular to that side. Even if you have to extend the side out to see that you are hitting that side. So this particular one, the orthocenter, can actually fall outside of your triangle because you could have an obtuse triangle and it could potentially fall outside of your triangle. All right, so when we do some constructions, you can see that it might fall outside. All right, so let's look at these next ones. The 3 altitudes then form the orthocenter, which is our last one that we're going to look at. The 3 altitudes form the orthocenter. So list the altitudes. Well, the altitudes here would be from the vertex perpendicular to the side, AE, from the vertex perpendicular to the side, BF, and then from the vertex C perpendicular to the other side, CD. Those are my 3 altitudes. My orthocenter then is the point P. You'll notice that it did not cut anything in half. Like this is not directly in the middle. F is not directly in the middle. It does not hit at a midpoint, but it is perpendicular. So the 3 altitudes of the triangle form the orthocenter. So let's look at this last thing, centers of triangles. The circumcenter then is created by the intersection of, circumcenter is 3 perpendicular bisectors. So this is going to be the 3 perpendicular bisectors. And I'm going to give you a little guided notes handout that we're going to fill these out for. The incenter is created by 3 angle bisectors. By the 3 angle bisectors of your 3 angles in your triangles. So the first one is bisecting your 3 sides. The second one is bisecting your 3 angles. The centroid is created by the intersection of your medians. Remember, the median goes from a vertex to the midpoint of the opposite side. So the median goes from the vertex to the midpoint. That is what a median is. The orthocenter. This is created by the intersection of the altitudes. And remember, your altitudes go from your vertex to the opposite side, specifically perpendicular to the opposite side. All right. So some of the special relationships that we saw within these. We saw that a circumcenter, which is your perpendicular bisectors, is the same distance away from all the vertices. So your circumcenter is going to be the same exact distance from each vertex. All right. The incenter, which was created by the angle bisectors, is the same distance from every side of the triangle. So the circumcenter, it is created by what? Yeah, so created by the perpendicular bisectors. So you could have just written perpendicular bisectors here, by the way. So created by the perpendicular bisectors. The circumcenter is equidistant from each vertex. The circumcenter is equidistant from each vertex. So in this particular triangle, that means that the distance from A to M will be the same as the distance from B to M, which will be the same as the distance from C to M. Because they are perpendicular bisectors, it means that each of those sides were also cut in half. So you have something like this created as well. Each side is also cut in half. So from the vertex to that circumcenter is all the same length. So these are all going to be the same length. And then your sides have all been cut in half. So that means that each piece of those sides will be equal to each other as well. The next one is the incenter. It is created by angle bisectors. This incenter is equidistant from each side of the triangle. So these are equidistant from each side of the triangle, which means that from M to X is the same thing as M to Y, which is the same thing as M to Z. Those are all the same. We also had some special things happen here with those, right? We also saw that, now I want to point out that this particular line, so like C is not turning there. Like C doesn't go through X, okay? Just make sure you understand that. C does not, that line from C to M does not go through X, all right? They have drawn that perpendicular to show the distance from there, okay? But once they put that point X, Y, and Z there, remember we also found that from A to X equals A to Z. So when you create those perpendiculars, you have the same distance. From B to X is the same as B to Y, right? And from C to Z is the same as from C to Y, all right? So keep in mind that those angle bisectors, if I were to keep drawing this guy out, it would not go through Z. They have drawn Z to show you the distance from the incenter to the side, okay? They just showed you that's the distance. The perpendicular distance is the distance, all right? But now that you have those distances marked, they create those special segments as well. All right, centroids, the one we just talked about. Centroids are created by medians. A median, what is a median? A median is created by a vertex that is connected to the midpoint of the opposite side. That is what a median is. And remember, the long piece of this median is exactly double the short piece of the median. Okay? The long piece of the median is 2/3 of the entire median, which means the short piece of the median is exactly 1/3 of the entire median. Okay? So you do have those special relationships that are created. The long piece is going to always be double the short piece of it. All right. And then the last one we talked about is an orthocenter, which is created by altitudes. An altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. All right.